You've been told the moon is a dead, dry rock. That lie is about to change everything you know about space travel. The lunar gold rush. Okay, so deep within the lunar South Pole lies the most valuable resource of the 21st century. And let me tell you, it is not what you think. We are talking about billions upon billions of tons of water ice. It's been locked away for eons at the bottom of craters so deep that sunlight has never, not once, touched their floors. Now, this isn't just some scientific discovery. This is the key to literally everything that comes next in space. I mean, just to put it in perspective, these are some of the coldest places in our entire solar system. We're talking temperatures that plummet down to minus 250 degrees Celsius. It's a brutal environment where almost nothing can survive. Except, somehow, this ice. And here's why this changes everything. See, in space, water isn't just for drinking. You split it apart, and you get hydrogen and oxygen. What's that? The two key components of rocket fuel. And if you process it another way, you've got breathable air for future colonies. Finding this much water on the moon means we may never have to launch another single drop from Earth. Hang on a second. You're telling me the moon has enough water to fuel 1,000 Mars missions? And enough to sustain permanent human colonies for generations. That's why whoever owns access to those craters owns the most strategic real estate in the entire history of human civilization. And this is where the story takes a much darker turn. For centuries, we've fought over oil fields and shipping lanes right here on Earth. Well, now, that very same kind of conflict is poised to play out 238,000 miles above our heads. Sometime in 2025, NASA's Artemis 3 mission is scheduled to land Americans near the lunar South Pole. But this isn't just some scientific mission. You have to understand, this is the starting gun. In direct response, the joint China-Russia Lunar Research Station program has massively accelerated its own timeline. And here's the absolute critical point. They are all targeting the exact same handful of resource-rich craters. They are not going to a different part of the moon. They are going to exactly the same place. And it gets even more complicated. You see, right next to these dark, ice-filled craters are what scientists call peaks of eternal light. These are ridges that are almost constantly bathed in sunlight, which makes them perfect for solar power. Now here's the thing. These peaks sit directly above the craters. So if you control the peaks, you control the power, and you control all access to the ice below. You essentially own the high ground. So how do you claim that high ground? Well, under the Artemis Accords, the U.S. has established this concept of safety zones. Officially, their purpose is to prevent operational interference. Basically to keep other missions a safe distance from American hardware. But when your hardware just so happens to be sitting on the most strategic real estate overlooking the most valuable resource on the moon, a safety zone starts to look a lot like a territorial claim. So it's probably no surprise that China and Russia have flat out refused to sign the accords. They're framing them as just an American attempt to unilaterally write the rules of space. The tension here isn't theoretical. And you have to remember, up there is no referee. Okay, this is getting intense. But how do you actually get water out of frozen lunar soil? I mean, it's not like you can just drill a well or something. No, you can't. The ice is all mixed into the soil. They call it the regolith, as these tiny frozen particles. So the plan involves sending autonomous rovers into total permanent darkness. These rovers are going to be equipped with thermal drills. They'll drill into the soil, heat it up until the ice turns directly into vapor. It's a process called sublimation. And then they'll capture that vapor before it escapes into the vacuum of space. From there, the captured ice gets transported to orbital refineries to be processed. Now, here's why that whole incredibly complex process is worth it. This number, over $20,000, is roughly the cost to launch a single kilogram of anything from Earth's deep gravity well. 1 kilogram. Now, just try to imagine the amount of fuel needed for a Mars mission. It's almost prohibitively expensive. But, and this is the game changer, if you can manufacture that fuel on the moon using what's called in situ resource utilization, well, you bypass that immense cost completely. You're no longer fighting Earth's gravity. The moon becomes a cosmic gas station, and it fundamentally rewrites the entire economics of space exploration. Exactly, and this is the part that I think most people are missing. The race for water on the moon has never really been about the moon. The moon is no longer the destination. It is the infrastructure. It's the central hub for an entire cislunar economy, fueling everything that comes next. So you'll have spacecraft heading to Mars or the asteroid belt, and they'll just stop at an orbital station, like NASA's planned Gateway, to top up their tanks with lunar-derived fuel. Think about this. Establishing a water-fueled launch infrastructure on the moon could reduce the cost of interplanetary travel by over 90%. All of a sudden, a $100 billion Mars mission becomes a $10 billion mission. The moon is not the finish line. The moon is the launch pad for everything that comes next. So wait, whoever controls the moon controls access to the entire solar system? Exactly. And the race is already on. And that brings us to the final, critical question about where all of this is actually heading. You see, the 1967 Outer Space Treaty clearly says no nation can claim the moon, but it says absolutely nothing about claiming its resources. The legal framework is 50 years out of date. So, right now, we face two possible futures. In one, nations come to the table, they create new treaties, and we all share in a new era of expansion. In the other, the race just accelerates. Nations establish facts on the ground, and the same conflicts we've seen over resources on Earth are simply repeated in space.
So which one do you think actually happens?
The way humanity resolves this question will set the precedent for how we manage every resource on every body in space for the rest of human history.
That's either the most hopeful thing I have ever heard or the most terrifying.